Now, example 3, we're looking at a geometric pattern that is created recursively. Okay? So example C, we are creating a triangle with triangles within it. And this is called creating a fractal, and it is the Sierpinski triangle. So we are going to use the first 3 stages to help us figure out how many triangles there are in the 20th stage. Okay? So we are going to start by setting up a table, writing a recursive rule, and then we can find the 20th term. Okay, so our stage 1, and we can kind of build our table into our information given to us, and we're counting the red triangles. So stage 1 has 3 red triangles. Stage 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. Okay, and if we count up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2 more sets of that, so 9 from this top one, 18, 27. This time when we're looking for the constant change, if you notice going from 3 to 9 and 9 to 27, there's not one constant thing you could add, right? 3 to 9 you add 6, but then 9 to 27 you add 18. So it's not a constant change of adding, it's a constant change of multiplying. 3 times 3 would give us 9. And 9 times 3 gives us 27. Okay, so our rule, starting with our starting amount, we've got the first stage has 3 triangles, and then any stage will be the previous stage times 3. Okay, and actually we like to write that with whatever's being multiplied out front. So what would be an even better way to write that is a sub 1 equals 3 and a sub n equals 3 times the previous term. Okay. It's not necessarily wrong if you write it the first way, but it does look cleaner to write it the second way. Okay, now we can use that to find our 20th term. Okay, so what I want you to do right now on your own is to continue our table out to the 20th stage to figure out how many triangles, red triangles, there are in that figure. Okay, and tomorrow we will compare answers, but also look at a shortcut on our calculator that we can use to get the same exact answer. Once you are done, unpause the video, and then we can talk about a general recursive rule for all geometric. Okay, so let's look at the general geometric sequence rule. Okay, first of all, a geometric sequence is a sequence in which each term is equal to the previous term multiplied by a constant. So arithmetic we add, geometric we multiply. This constant we call a common ratio. So our common ratio above was 3. If we generalize it and call R our common ratio, then we have a recursive rule in the form of a sub n equals whatever our ratio is times the previous term. Okay, and remember, as always, you always need a starting point.